Hey grade 9, welcome to Unit 3, Section 2, Solving Equations by Multiplication and Division. So in this lesson we're going to learn to solve linear equations using multiplication and division. So recall from last lesson, we solved equations that had, some terms, some constants, or even some linear terms on either part of the equal sign, right? And we did this by moving the variables all to one side and the numbers all to another side. So let's take a couple minutes now to complete these review questions. Pause the video now and take a crack at these questions, and when we resume in a minute, I will put the solutions up so you can see the answers. Okay, so hopefully you've had a chance to try these. Here are the solutions. Okay, and so how do we do these? Well, for number one, I had this double negative, right? And so, of course, changing that to a positive right away was the first step. Then we had to get x alone on the left side. And so because we had x plus 2 there, I decided to subtract 2 from both sides, here and here. Now, you don't have to show this step, right? Really, what can happen is you can just move this plus 2 to the right and make it negative, right? Which is essentially what happens, right? X plus 0 is equal to negative 11 minus 2, and that becomes x equals negative 13. Okay, for number 2, here, because we had a 5 and a minus x, right? This time I took the 5 and moved it to the right. There it is, minus 5. So subtracting 5 from both sides, canceled the one on the left, and created one on the right. But that leaves us with negative x, okay, on the left, right? So after we finish combining 12 and minus 5, we get 7. And then it's a matter of switching the signs to finish the question. So we get x equals negative 7. For number 3, this one, well, we have variables and numbers, constants, linear terms and constants on both sides of the equation. So it's a matter of moving both 4x and 5x to the same side, to the left in this case, is which side I've chosen, and moving minus 9 over to the right side with negative 11. And of course, when we add 9 to both sides, it becomes positive over here and cancels on the left. And when we subtract 5x from both sides, okay, it becomes negative over here. There's the subtraction, and it cancels on the right. And so then we're ready to collect like terms. So we end up with 4 minus 5, so negative x, and on the right we get negative 11 plus 9, which is negative 2. Switch the signs, and that gives us x equals 2. Okay, and finally, for number 4, x minus 16 equals 0. How did we get that? Well, really, I noticed that we had minus 12x's and plus 13x's, which adds to 1x, right? One positive x. We also have minus 5 and minus 11, which is a total of minus 16. And so combining those two things together gives us this x minus 16 equals 0. And then, of course, all we have to do is move this negative 16 to the right, where it becomes positive, and we're done. So this process of moving terms from one side of the equation to the other is useful whenever we want to collect like terms that are spread out anywhere over the equation, and we can use addition and subtraction for that. However, what do we do if we have something like this? So look at this example 1 here. 5x equals negative 35. What this means is not 5 plus x, of course. This means 5 times x. In other words, this essentially means 5 times something equals negative 35. Now, some of you probably can put up your hand right now and answer that right off. But learning the process, just as before, of using inverse operations to solve these is what's going to get us all the way through to the hardest of all the equations that we'll be working with. So let's just go through this blurb real quick here. So when solving equations for a variable that's multiplied or divided, we can't add or subtract the number to move it to the other side. Instead, we use inverse operations, which are operations that undo each other. And addition and subtraction are, in fact, inverse operations. To cancel addition, you can use subtraction, and vice versa. Multiplication is the inverse operation of division. So how do you think that we could isolate x here using algebra? So the answer, of course, is to divide both sides by 5. Because we have 5 times x, and we want to cancel, we want to get rid of this 5 somehow, we can use the opposite operation to multiplication, which is division. And so what will happen is we'll get this. Oops. Okay, so if we have 5x equals minus 35, to show that we're going to divide both sides by 5, we can actually just use big fraction lines, put a great big division symbol line underneath each side. And what we're doing here is we're dividing both sides by 5. And this is allowed because this is balancing an equation, right? Whatever you do to one side, you must also do to the other side. Now, do you see here how on the left side, dividing this by 5 basically allows us to cross-cancel these 5s. So we end up with just x equals, and on the right, we have minus 35 over 5 divided by 5, which is minus 7. Okay, let's try it over here. So for number 2, we have x divided by 12 equals 9. Now the goal, remember, is to get x alone. Right? We want to get x all by itself, in this case, on the left side. And what we currently have with x is a division. So the inverse operation to division is multiplication. Why don't we just multiply both sides by 12? So let's do that. So what do we get? Well, we would get 12 times x over 12 is equal to 12 times 9. Now what this does, of course, is it allows us to cross-cancel on the left these 12s, just like before. And on the right side, we're left with simply just 9 times 12, which is 108. Okay, so let's do a bunch more examples. So number 1 here, 3x equals negative 69. Well, here, again, what we can do is just divide both of these guys by 3. Right? What that's going to let us do is cancel the 3 on the left, and we end up with negative 23. X equals negative 23. For number 2, we again have a multiplication here, and this is a decimal, so really we're just going to need a calculator for this one. Right? So if we have 4.9x equals 29.4, we can divide both sides by 4.9, like so, and we can pull out our calculator, and yielding, let's see, punch that in, and we get 6. There we go. Okay, next page. Example 3, well, in this one we have 108 equals negative 12y. This time, notice how the variable's on the right. But don't let that scare you. You can still go ahead and just divide both sides by minus 12. Okay? And of course, we pick that number because that's the number that's with y, right? A negative 12 times y. So we use inverse operation of division, and we end up with the following. Well, we get negative 9 on the left is equal to y. And you can just leave it like that. There's nothing wrong with leaving your variable on the right side. How about number 4? Well, this time we have some like terms, right? 2x minus 11x. Well, we can do that. That's just minus 9x. Right, is that equal to 54? And then to solve for x, we need to divide both sides by minus 9. And we get x equals negative 6. How about number 5? Well, number 5 simply has 13 equals x over 14. Right, we have a division. So what do we need to do? Multiply. Right, so we can multiply both sides by 14. Right, so we're going to get 14 times 13 equals 14 times x over 14. And of course, this 14 is technically interacts with the top here, this x variable, right? You can think of this as just another fraction with a denominator of 1. Although that doesn't line up very well, but still, right? We can therefore cross-cancel these 14s, and each would become a 1. And we're left with just x. And then we need 14 times 13, which is 182. So we get x equals 182. And in fact, in this step, if you want to, you can just reverse the sides and write it just like that. Number 6, negative x over 2 equals negative 11.5. Well, this time, there's a negative sign in front of the fraction, but really, we can still multiply this by negative 2, and that should get rid of the sign and get rid of this division at the same time, right? So if we go negative 2 times negative x over 2, and I'm just using brackets here just to be careful with signs, And then we'll have negative 2 times negative 11.5 on the right. Well, now notice on the left here, we're going to have two negatives, right, multiplied. Those are going to cancel. We're going to get a positive, and so that's going to clean up the sign. We're going to have just x left because these cross cancel, right, these 2's. And so we'll have left just x equals 2 times 11.5, which is positive 23. All right, we got one more example here, number 7. So this time, notice how we have x over 2 minus 1 equals 7. And really, for this one, it's just a matter of, first of all, taking care of this little minus 1 first. This is kind of a preview of tomorrow's work. We'll do it quickly here, but we'll learn how to do this basically in more detail in the next lesson. Okay, so x over 2. Well, we have this minus 1, so what we could do is add 1 to that. That's going to get rid of it there, and it's going to bring a plus 1 to the right, right? And so, oops, not 8, just 1. There we go. So we move that minus 1 over, it becomes plus 1. Now we have just x over 2 equals 8. Right, and so really it's just a matter of getting rid of this division. We can double both sides, multiply by 2, that gives us x equals 16. And we'll be done. Okay. So these examples down here are some special examples that I just want to end the lesson with. The first one, 2x over 3 equals 12. Well, this is a case where we have both division and multiplication with the variable on the same side, right? We have 2 times x, but all of that is divided by 3. And so really, what we can do is a little trick for this, and we can kind of clear them out in the exact same foul swoop. So we could actually just take our time and divide both sides by 2 and then multiply by 3, but it's much better to just multiply both sides by the reciprocal. And I'll show you what that looks like. So the reciprocal of 2/3, that's the multiplication and the division, is of course 3 over 2. So watch what happens when we multiply both sides by 3 over 2. Well, we're going to get 2x over 3. And on the right, we're going to get the reciprocal again, times 12. Okay, and so can you predict here what's going to happen now? Let's have a look at, right, on the left. Well, we have everything multiplied on the top, 3 times 2 times x, and then again on the bottom, 2 times 3. Remember that, right? When you're multiplying two fractions, the tops multiply and the bottoms multiply separately. And if there are any common factors in the tops, in the top and the bottom, then we can cancel them out. We can cross cancel them, right? And so the 3's cancel off and the 2's cancel off, leaving us with only, okay, well, these would all become 1's, right? Which are trivial. We don't need to write them. 1 times anything is just 1. And so we're left with just x on the left, which is super cool. On the right, we have 3/2 times 12. Well, that 3 is going to interact with the 12, right? So we could multiply that, get 36. Or if you happen to notice that we have a multiple of 2 on top, then we could cross cancel here. This is going to be 1. This would be 6. And of course, we're going to have 3 times 6, which is 18. Okay, example 2. So in this case, here we have a division, but on the right side we have this fraction, right? 2 over 11. Well, don't let this fool you. Really, all we're dealing with here is an x that's being divided by negative 3. So really, we just got to multiply that by minus 3. So minus 3 times x over minus 3. This is going to isolate x. And on the right, we're going to have minus 3 times 2 over 11. Okay, so we end up with just plain old x equals negative 6 over 11. And the only thing different about this is that we had this fraction on the right, and so we had to make sure to multiply minus 3 by the top by 2. All right, the last example is very similar to the first one, but the only difference here is that instead of the x being kind of on top like this with the 2, it's sitting to the side of the fraction. But really, don't let this fool you. Okay, this x is being multiplied by 5 and technically divided by 6, right? And so you can use the same strategy here. We can multiply by the reciprocal of the coefficient on x, which is 5 over 6. So the reciprocal, of course, is 6 over 5. Let's do it. So we're going to get 6 over 5, right, times 5 over 6, x, is equal to 6 over 5 times 5 over 4. And now, because we chose the reciprocal on the left, these all cross off, and we're left with just x equals, well, let's have a little look on the right here. Notice how we have, well, we've got 5s that can cross cancel, right, on the right. And we also have multiples of 2, right? We have, you can divide these both by 2. You're going to get 3 and 2 on the bottom. So we're left with x equals 3 over 2. Okay, that's it for this lesson. Give these a try on the handout that follows, and just so that we can keep things moving, I'm going to restrict this homework assignment. I want you to do only the odd numbered questions. Okay, good luck with those, and we'll see you in the next lesson.